Hello students, welcome you to this video. So the previous video I taught how to find area, right, using integration. So we have uploaded two videos for that. All the exercise 10 questions, first 5 in one video and the next 5 in another video. In this video we are going to discuss how to find volume of a solid, right? So for a 3-dimensional only you can find volume. So how to find volume using integration. Okay, so just I'll explain two formulas you have to study. So when a curve revolves about x-axis or y-axis, you will get a solid, right? Just to consider, say x-axis, y-axis. Suppose a line is like this. This is a line. When this line revolves about x-axis, so this is the axis. So when it revolves, you will be getting a cone like this, right? You will be getting a cone. So you are getting a solid. So how to find volume of that? Or suppose you consider a rectangle. When this rectangle revolves about x-axis, what do you get? Can you imagine? When this, you can see that in a sheet of paper, just to paste it in a stick, just to rotate. So when it revolves, you can see a cylinder, right? So here, when this rectangle revolves about x-axis, you will be getting a cylinder like this. Okay, so when this portion revolves, you will get this also at a time. So in area, what we do? So when you find this portion like this, one more, you multiply by 2. But here not like that. When a curve revolves, you are getting the solid, right? So when the first quadrant portion revolves, you will get these two at a time, right? But if we have a curve like this, so when this portion revolves, you will get this also at a time. Like this, one more portion. So in that case, you have to multiply by 2. So remember, in area where we multiplied by 4, here we multiply by 2. Where we multiplied by 2, here you don't multiply anything. Okay, so that's one change. Then formula, there is a small change. In area, we study two types of formula. Area bounded on x-axis and bounded on y-axis. On x-axis, integral a to b y dx, right? But here the formula, pi into integral a to b y square dx. Okay, this is the formula to find volume when the curve revolves about x-axis. So this is the first one, volume of a solid obtained by revolving area about an axis. So when it revolves about x-axis, the formula v equal to pi into integral a to b y square dx. Okay, and when the curve revolves about y-axis, a small change, instead of y square you write what? X square. So outside there is a pi into integral a to b x square dy, pi into integral a to b or c to d, the limit we are going to write. Okay, x square dy. So very simple topic this one. Only thing you have to understand the curve and you have to imagine when it revolves, so what you are going to get, right? Let's move on to the first question. Please listen. Find by integration the volume of the solid generated by revolving about x-axis. So you immediately know the formula. When the curve revolves about x-axis, what's the formula? Pi into integral a to b y square dx, right? The region enclosed by the curve is given y equal to 2x square. Y equal to 2x square. X degree 2, y degree 1, right? So x square is equal to y by 2 type, right? X square equal to y by 2. X square equal to 4ay. So it is the third type parabola, open upward. Okay, so this is that curve. X square equal to y by 2. Y equal to 0. Y equal to 0 means x-axis. And x equal to 1. X equal to 1 revolves about x-axis. See, this point is 0. If the limit is not given, put x equals 0, right? About x-axis means you put y equals 0. When you put y equals 0, 2x square 0. 2x square 0 means x square 0. So x equals 0. X equals 0 is 1 point. Another one x equal to 1. So x equals 0, x equal to 1 somewhere here. Okay, x equal to 1. So x equals 0, x equal to 1. When this curve revolves about x-axis, you will be getting a solid like this, right? So we want to find volume of this solid. Okay, this is what they asked. Okay, this is the solid we have to find. This volume of this solid we have to find. So here x varies from 0 to 1. X varies from 0 to 1. Then we want y square. In the question they given y equal to 2x square, right? Y equal to 2x square. So y square is 4x raised to 4, right? Now you can write volume. Volume equal to pi into integral a to b, what's the formula? y square dx, right? Revolves about x-axis. So that is pi into limit 0 to 1. Y square is 4x raised to 4. So now we integrate. 4 is a constant, take it out. So 4 pi into x raised to 4 integration x raised to 5 by 5. Limit 0 to 1. So the 5 also take it out. 4 pi by 5 into only x raised to 5. When you give the upper limit 1, 1 raised to 5 is 1, minus 0 raised to 5, it is 0. So the final answer is 4 pi by 5. We are finding volume, so you write cubic units. Okay, now let's move on to the next question. Look at this question. Find by integration the volume of a solid generated by revolving about x-axis only. The region enclosed by y equal to e raised to minus 2x. Some curves here to remember, okay? So y equal to e raised to minus 2x. So here the curve will be. So one point you can find very easily. When you put x equal to 0, what is y value? E raised to 0. Any number raised to 0 is 1. So 0, 1 this point, okay? The curve passes through this. So as x moves, as x is increasing, the values will decrease. And the other side, the values will increase. So the curve will be like this, okay? This is the rough diagram of y equal to e raised to minus 2x. Y equal to 0. Y equal to 0 means it is x-axis. X limit they given clearly here. X varies from 0 to 1. X varies from 0 to 1. Says x equal 0 is here. X equal 1 is somewhere here. X equal 0 and x equal to 1. So when this portion revolves, when this area revolves about x-axis, you will be getting some portion like this, right? Like this, okay? So this is the solid you are getting. Its volume we have to find. Are you able to understand? So we have to find the volume of this portion. Okay, so this is the volume we have to find. And what's the limit given here? 0 to 1, right? 0 to 1. So x varies from 0 to 1 and we need y square. Y equal to e raised to minus 2x. This is what given in the question. We need y square. So y square is equal to e raised to minus 2x the whole square. E raised to minus 2x the whole square. A raised to m the whole raised to n is a raised to mn, right? So y square is equal to e raised to minus, multiply that 4x, right? 2 into 2. So now you can write volume. Volume is equal to pi into interlate to be y square dx. Here the limit is 0 to 1. So pi into integral 0 to 1 y square e raised to minus 4x dx. Now integrate it. So pi into e raised to minus 4x integration. E raised to minus 4x by minus 4, right? That minus 4 I am writing here. Minus 4. Limit 0 to 1. So that is minus pi by 4 into, give the upper limit 1 first. So e raised to minus 4 minus 0, you give e raised to 0. Any number raised to 0 is 1. This minus you take inside, so you have to reverse it, right? So pi by 4 into 1 minus e raised to minus 4. By this minus you multiply. So the minus become plus and the plus become minus, that much cubic units. Now let's move on to the third question. Listen carefully. Find by integration the volume of the solid generated by about the y-axis now. Revolved about y-axis. So you know the formula, pi into integral a to be x square dy. So we want x square. It's in the question they given x square itself. X square equal to 1 plus y. This represent what? This represent a parabola, right? X square is equal to y plus 1. This is a parabola. What else you know? Which type parabola? X square equal to 4ay. Open upward, right? Can you say the vertex? It is not passing through the origin. It is not like this. Normally we draw like this, okay? So it is not like this. It is not passing through the origin. If I put x equals 0, I won't get y equals 0. Y equal to minus 1, right? So here the vertex is 0, minus 1, right? 0, minus 1. So this is not the curve. 0, minus 1. X value 0, y value minus 1. So the curve will be like this. So just I'm giving a rough diagram first. Okay, now about y-axis. So other limits not given. Y-axis means you put x equal 0. When you put x equal to 0, you will get 1 plus y equal to 0. 1 plus y equal to 0, so y equal to minus 1. This is one limit. Another limit they given, y equal to 3. It is given in the question, y equal to 3. So y varies from minus 1 to 3. Listen, y equal to minus 1 is here, say 3 is somewhere here. Minus 1 to 3, when this curve revolves about y-axis, you will be getting a solid like this, right? We have to find the volume of this solid. Hope you understood. We have to find the volume of this solid. It revolves about y-axis. Okay, so y varies from minus 1 to 3. Y varies from minus 1 to 3. And we want x square here because revolves about y-axis. X square value, we got it 1 plus y. 1 plus y. So the required volume is equal to pi into integral a to b x square dy. So that is pi into integral a to b minus 1 to 3 x square value 1 plus y of dy. Now we integrate it, very simple integration. So pi into 1 integration y because with respect to y, right? Plus y integration y square by 2 limit minus 1 to 3. So that is pi into. So first you give the upper limit. Upper limit you give 3. So y value 3 plus 3 square 9 by 2 minus of. Now we give the lower limit minus 1. Y value minus 1. So minus 1. Plus, because minus 1 square is 1, so 1 by 2, right? Now we simplify, so pi into 3 plus 9 by 2 minus into minus is plus 1 minus 1 by 2, right? So integer part is simplify first. 3 plus 1, 4 plus 9 by 2 minus 1 by 2. 2 LCM, 9 minus 1 is 8 by 2, so that is another 4. So 4 plus 4 is 8. So your final answer is 8 pi cubic units, right? Okay, now let's move on to the fourth question. Listen carefully. The region enclosed between the graphs of y equal to x and y equal to x square, both familiar graphs only, y equal to x, another one y equal to x square. This is a parabola. X square equal to 4ay type, open upward, right? X square equal to 4ay. And y equal to x is this line. But both you draw in a same diagram, right? The region enclosed between these two graphs, right, is rotated through 360 about x-axis. Okay, the portion between these two, not the entire curve. So in area we study, no? Area between two curves. Area bounded by the upper curve minus area bounded by the lower curve. Same way here also. Suppose some hollow cylinder, outer cylinder minus inner cylinder, right? Same way here. So here this is, listen, this portion is revolving. So parabola equation y equal to x square, y equal to x square, and the lines equation y equal to x. We have to solve it. We have to find the limit. Y equal to x square and y equal to x. Left sides are equal. You can equate the right sides. So when you equate the right side, x square equal to x. Bring it to the left side. X square minus x equals 0. Take x common. X minus 1, 0. So two possibilities, either x equal to 0 or x equal to 1. So x varies from 0 to 1, right? X varies from 0 to, so this point is 1. Please listen, only this portion is revolving. This portion is revolving about x-axis, right? So inside you can see some hollow part, right? So you'll be getting a line here and here some curve like this, right? So like this, only this portion is revolving. This is not, this portion revolving, this is empty space, okay? So it's a hollow one. So volume is only these two, this portion, right? Not these two, the entire one, it revolves 360 degree, right? Okay, like this only we can show for the, in the diagram, right? But for the examination, this is enough. You no need draw. So main curve, this one, this is the curve you need, right? When this is understood. So y equal to x square equal to y, open upward parabola you draw, and this line you draw, shade this portion, limit 0 to 1, even that is enough for the examination. For you to understand, just I'm showing this diagram. So when this portion revolving, right? Suppose a line alone revolves, you will get a cone, right? This curve alone revolves, you will get this portion, right? So we want in between. So volume bounded by the line minus volume bounded by that curve, right? So pi into integral a to b y1 square minus y2 square, right? So the required volume is equal to actual formula pi into integral a to b y square dx here between. So y1 square minus y2 square dx. y1 square is y square from the upper curve. Here the upper curve is what? The line. So from the line you have to find. So pi into integral limit 0 to 1 y square from the line. What is y value? X. So y square means it is x square minus y2 square, that is y from the lower curve. Lower curve is the parabola. So there y value x square, we want y square, so you will get x raised to 4 of dx. Now it's very simple calculation, right? So that is pi into x square integration x cube by 3 minus x raised to 4 integration x raised to 5 by 5 limit 0 to 1. So that is pi into upper limit 1 you give 1 by 3 minus 1 by 5, 0 when you give both the term becomes 0, right? So that is pi into, take LCM 15, 5 into 1, 5 minus 3. So 5 minus 3 is 2. So 2 pi by 15 cubic units. Okay, now let's move on to the next question. Here the diagram is given in the question. Find by integration the volume of the container which is in the shape of a right circular conical frustum as shown in the diagram. Okay, so everything they mentioned there. So the height is 2 meter. The lower end, the radius is 1 meter. The top, the radius is what? 2 meter. The lower classes you would have studied mensuration, right? But here using integration, we have to find the volume, right? So there we take R1, R2, H, right? Okay, now. So what you can do, you find this one, when this portion revolves about y-axis. When that becomes symmetric about that y-axis, right? What I shaded now, when that portion revolves about y-axis, you will get the entire solid. So we take this as x-axis, okay? This as x-axis and this as y-axis. So this point is 0, right? So this is one point, this is another point. Actually, if you say this line is revolving, that's all. The line AB revolves about y-axis, you will get this solid, right? The AB revolves. So can you say the coordinate of A? It is on x-axis, so y coordinate is 0. Y coordinate is 0. X length is 1. So 1, 0. B is a point here. X coordinate, this length. So 2. Y coordinate is also 2. So it is 2, 2, right? 1, 2, 2, 2. So this is the diagram you are getting, right? X-axis, y-axis. This point is A. This point is B, right? AB revolves about y-axis. A is the point. The coordinate is 1, 0. B's coordinate 2, 2, right? Because if I draw like this length and this length are same. It is 2, right? X coordinate is 2 and Y coordinate is 2. Height, it is given. So 2, 2. The line AB revolves. A is 1, 0 and B is 2, 2. Revolving about y-axis, so y limit we need. So here you see, here y value 0, here y value 2. So y varies from 0 to 2. Y varies from 0 to 2. Now only thing I want equation of AB. From that you find y square. Not y square, x square. Because revolving about y-axis, right? Pi into integral a to b x square dy. So first you find equation of AB. So equation of AB. 2 points we know, so use 2-point form. What is 2-point form? Y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So this is our x1 y1 and this is our x2 y2. Substitute the values. Y minus y1 0 by y2. y2 is 2. 2 minus 0 equal to x minus x1 is 1 by x2 is 2 minus 1. So y by 2 equal to x minus 1 by 2 minus 1 is 1. Leave it, right? So we want x only, no? Bring that minus 1 here. So x is equal to y by 2 plus 1. So x is equal to, take 2 as LCM, y plus 2. This is x. We want x square. So y plus 2 the whole square by 4. If you want to expand that, because when you integrate you have to expand it. A square minus 2ab, 2 2s are 4, 4y, not minus, plus 4y, plus b square, 2 square is 4, divided by 4. Okay, that you can write outside, right? So now you can write the formula, volume is equal to, revolved about y-axis, so pi into integral a to b, x square dy. That is pi into integral, what's the limit here? 0 to 2, right? Limit is 0 to 2. X square, what is x square value? Y square plus 4y plus 4 by 4, that 4 you bring it out, right? Of dy. Now we integrate and apply limit pi by 4 into y square integration y cube by 3 plus 4 into y square by 2 plus 4 integration 4y, limit 0 to 2. Upper limit 2 you give, lower limit when you give 0 everything will be 0 only, right? So that is pi by 4 into upper limit 2 you give 2 cube, it is 8 by 3. These two can cancel, you are getting 2. Y you are giving 2, so 2 square 4, 4 2s are 8 plus 4 2s are 8. Minus, when you put 0 every term becomes 0, right? So pi by 4 into 8 plus 8, it is 16. 8 by 3 plus 16. Now we take 3 as LCM. So pi by 4 into, take 3 as LCM, you will get 8 plus 48, right? So pi by 4 into 56 by 3. Cancel 4 table, you will get 14. So the final answer is 14 pi by 3 cubic units, but here they given some unit, right? 1 meter, 2 meter, it is given in meter, so you write cubic meter or you write meter cube, right? Because we are finding volume cubic units. So hope you understood this one. So this is a diagram. The diagram, everything they given. We want to find the volume of this solid. So revolves about y-axis, easily can do that. Now let's move on to the last question. This exercise, very simple one. A watermelon, it is in the shape of an ellipse, right? So for ellipse, you know, there are two types of ellipse. Major axis is along x-axis, that is the first type, right? Which can be obtained by revolving an ellipse with major axis 20. Length of the major axis 2a. 2a is 20, so a equal to 10 centimeter. Minor axis, that is 2b is equal to 10, that is b equal to 5 centimeter. Major axis 10, so this length is 10, this is 5, right? We have to find the volume, so we use x-axis. So x varies from 0 to 10. So when this portion revolves, you will get these two at a time, right? But like that, one more portion is there, no? So that volume that you multiply by 2, okay? So because like if it is area, we would have multiplied by 4. We find the area in the first quadrant. But here, the first quadrant portion revolves about x-axis. The first quadrant, fourth quadrant, together you will get. But like that, one more portion, so you have to multiply by 2. And we need y square, so we start with equation of ellipse, right? So it is the first type. So equation of ellipse. X square by a square plus y square by b square equal to 1. That is x square by a square means 10 square, it is 100. Plus y square by b square is 25, right? 5 square, 1. From here we need what? Y square. So y square by 25 is equal to 1 minus x square by 100. So y square by 25 is equal to, take 100 as LCM, 100 minus x square, cancel 25 table, you are getting 4, right? So y square is equal to 100 minus x square by 4, and x varies from 0 to 10, right? So now with this idea we find volume. Required volume you write. Because volume formula pi into integral a to b y square dx. This is the actual volume. But here like that one more portion is there. So 2 into. So that's the reason we write required volume. That is 2 pi into limit 0 to 10 y square 100 minus x square by 4. That 4 I am writing outside of dx, right? Now cancel 2 table. So you are getting pi by 2. 100 integration 100x minus x square integration x cube by 3 limit 0 to 10. That is pi by 2 into, first you give the upper limit 10, 100 into 10 it is 1000 minus 10 you give 10 cube again 1000 by 3 minus when you give 0 both the term becomes 0, right? So you are getting pi by 2 into take 3 as LCM 3000 minus 1000, right? So that is pi by 2 into 2000 by 3. 2 table you cancel, you are getting what? 1000. So the final answer is 1000 pi by 3 cubic units, but here they given some unit, right? Centimeter. So you write what? Centimeter cube. So hope you understood all these things. We'll continue in the next video.